In this collection of videos, we are going to be talking about branching and the Boolean data type in C++. Before we can begin discussing that data type and that control structure, we first need to discuss what the flow of control means within a program. Up until this point, we haven't mentioned flow of control because it has been fairly intuitive to us, meaning that we have been reading our programs and what's going on in our IDE much like we would be reading a book, meaning that we have been reading the code in our IDE in a manner that is sequential, where all lines of code have been executed once and only once, and the line of code has generally been read from the left to right. So except for one exception, which I'll mention in a moment, we haven't mentioned flow of control because it's been very natural and has aligned with things that we're used to since childhood. The diagram on the right shows what the flow of control in our program looks like when it is being read sequentially. We read line 1, line 2, line 3, line 4, and at each opportunity of these lines, we should be generally reading left to right. Now, the one example that we've seen of this thus far is when we have reassigned values to variables, like so. And this was an exception to the third rule where we read code from left to right. So taking just this first line as an example, x is assigned the value of x plus 1. We don't actually read that code entirely from left to right. When I say it out loud, I read it left to right. But what the computer is actually doing is the computation on the right-hand side of the assignment operator or equal sign, because that is the lookup of the current value in x, which is then incremented by 1. And then the second part of executing this line of code is to compute that value and store it within the variable x. So a line of code, like x is assigned the value of x plus 1, is actually read right of the equal sign to the left of the equal sign, as opposed to being read from left to right. Other than that exception, we have mostly seen flow of control following the rules mentioned on this slide. However, there are plenty of times in life where we don't follow procedures that are read line by line, everything executed once, and done in a sequential order. There are times in life when we do things repetitively. There are times in life when we make decisions to do one thing over another. And one thing we do in life when we're trying to make a decision about what path we're going to follow is we often make these things called flowcharts. And I have here for you a humorous example of a flowchart determining whether or not we should eat some food that has fallen on the floor. And so we make these flowcharts and we ask ourselves these questions, and based on our answers to the questions, we may or may not change our behavior. And this is the type of situation that we're going to use branching within our computer programs to model. Now, it's best to start small when talking about branching. So I've simplified the example from the previous slide to just a more general statement about what does it mean to branch. And what it means to branch is to have some sort of question that we want to ask, and based on the answer to that question, we may wish to have different behaviors. And what that's going to look like in our code is we're going to have some sort of code that our flow of control had been following prior to the branching statement. And then we want this ability to ask a question. I have a statement. Is this statement true or is this statement false? And in the event that the statement is true, we may want to do one thing. In the event the statement is false, we might want to do something different. And then once we've chosen our path, there's more code for the program to do. And so we would like for our code to converge back and continue from there, regardless of whatever path we've chosen. So the less formal picture or flowchart is shown here on the right, and then the actual C++ syntax for what that's going to look like in our code is here on the left. So following through matching up the syntax with our picture, what we have written in line 9 is there would be some code within our program that comes prior to our branching statement, and that's equivalent to line 9 over here. And then in our flowchart, we ask the question. We have some sort of question, we have some sort of statement, and we ask, is this statement true? And the syntax for that is shown on line 11 over here. We're going to be using the word if, we're going to need some parentheses, And we're going to have something that we are checking within those parentheses. Is this statement true? A really keen eye will notice that there are double equal signs here, and that is important and will be discussed later. Following line 11, we have a set of braces on lines 12 and 14. And then in between lines 12 and 14, we would write in what code we would like followed in the event that this statement actually is true. So in the event that we go down the left-hand side in this flowchart, there's something we want to do if the answer to that question is yes or the statement is true, and it's that code that we would put right here in line 13 of our program. And what's interesting then is that the things that come within the braces after the else, in between lines 16 and 18 that I have boxed off in red here, in the event that our statement is true and we follow the code that is in between the braces right here, everything that is inside these braces, line 17, will be entirely ignored, and this chunk of code will be skipped, not read at all. Conversely, if when we ask this question, is the statement true, and the statement's not true, in other words, it's false, then the code that's going to be skipped is all of the code between these two braces, between lines 12 and 14, will not be executed when we run the program. And instead, that code that appears inside the braces between lines 16 and 18, that code will in fact be the code that is run in the event that the statement is actually false. And no matter what branch we follow, flow of control resumes on line 20, and the rest of the program is executed from there. So it's important to know that within your code, you're going to have to think of every possibility, what happens in one case and what happens in another, and you'll have the code for both situations in your program. But when the program is run, only one of these two chunks between 12 and 14, or 16 and 18, will actually be executed. The other chunk of code will not be executed at runtime. So despite the fact that reading in a book, we would need to read all things, the program is only going to choose one of those paths between 12 and 14 or 16 and 18 based on the answer to the question in line 11 when the code runs.